Okay, I wanted to talk a little bit about a hobby project that I've been doing for a little bit now, a few hours on the weekends, for more weekends than I want to admit, thinking about building a new engine for the TeX typesetting system, right? TeX and LaTeX is something that I use every day as part of my work. I love the quality of the output. I love working with it. And maybe even more so, it's humbling to think about using technology that was written, in many cases before many of us were born, but is still so solid and, productive today. And also, I have to admit, looking at the original source code was something that really taught me a lot about scientific programming, right? And thinking about how data wants to flow through the code that we write, really, I think, quite inspiring for me. So while this is building, let me just keep chatting a little bit. So, one of the things that I kind of started thinking about was this question of, TeX was written TeX was written in '82, and a lot has changed since then. We know a lot more about what we want as the output. We're not looking for DVI. We're looking for not just PDF, but tagged PDF with accessible features. We want, to use OpenType fonts instead of TFM files and things like this. And, I kind of started wondering, if you were designing TeX today, but knowing what we want the kinds of outputs to be, what kind of decisions would you make differently? And especially, what kind of decisions would you make differently if you still wanted it to be TeX, right? You still wanted it to pass the trip test, work in exactly the same way as a macro expansion language, and be compatible with all of the existing TeX files that have already been written. Right. So I just wanted to kind of demo a few of the things that I've been building as I work towards this goal. There's a lot still to do, but I thought it was in a kind of a state where it might be interesting to start sharing. So first, let me just copy some stuff from some other directory. You can see that when the project builds, it kind of makes some format files already, and I just copied some TeX files and samples and things like that. So one of the first things that I maybe wanted to show was, I remember being shocked when I discovered just how much faster it is to compile documents in the plain TeX format than it is to use LaTeX. I remember being just absolutely floored by this. And so maybe one of the first things that I want to show is just, plain TeX compiling some document in about, 80 or 90 milliseconds or something. And what was the thing that we just built? It was this, beautiful 90-page document with math and footnotes and, no images, but a bunch of different fonts and, oh my gosh, 80 milliseconds. That sounds pretty nice relative to how long it usually takes me to compile stuff. Well, maybe we can aspire to think about doing things a little bit better, a little bit differently. So let's try to compile exactly the same file. Let's specify that I want the plain TeX format, and I need to tell the engine that I'm going to compile for a PDF. And, you get something that is kind of comparable, maybe a little bit faster. Some of that additional speed is due to things that don't make it a one-to-one comparison. I'm not using a lot of file searching. I've kind of put all the files I need exactly where I need them. So some things aren't fair, but some things really are. I'm doing, I think, some interesting thinking about where the data actually wants to be and how it wants to be arranged under the hood. Okay. But more important, I think, than just this demonstration that maybe you could build a better PDF TeX, you could say, we know in advance that modern hardware wants to run processes concurrently. We want to be doing as much work in parallel as possible. And even before you get to the problem of, well, in a macro expansion language, how do you, even think about parallelizing the process of breaking up your source file and doing chunks of that in parallel? You know that your output is going to be PDF. And there's all kinds of work that can be done, subsetting fonts and compressing and preparing each of the pages. There's lots of work that can be done asynchronously, and so maybe you should. And it looks like I'm running OBS in the background, so this is maybe not exactly as fast as it usually is, but there you go, 35 milliseconds. That's something that really makes you start thinking about doing live rendering of your document as you're working, not just in a kind of incremental compilation space, which there's been a lot of progress on recently, but just recompile the whole thing from scratch every time, and it only takes 30 milliseconds to do 90 pages or something. Okay, that's kind of interesting, but that's kind of, I think, just one of the first kind of architectural consequences of thinking about this way. But another thing that we kind of, I said we knew in advance, was that we wanted to be able to have, modern fonts and to have tagging as a first-class citizen. So let's imagine that we want to use a variation of the plain TeX format, which kind of has some extra things about, well, using OpenType fonts instead of TFM fonts by default and stuff like that. I'm still going to compile it for a PDF. No need to use, well, I guess we can use the async flag if we want, and let's do the variation of this gentle.tex document, which I just adapted very lightly in order to make use of some of the primitives that I've built into this. You can see that was still almost instantaneous. That was probably about 150, 200 milliseconds. And what is this document? It's well, it's the same thing. It's the same, guide written by Michael Dube about using TeX and plain TeX, except, it's using different fonts. It's got links and annotations, and it's using an OpenType math. So I've basically implemented a subset of the Unicode math package, extensible, accents, and all of that kind of complicated stuff. But just done at the engine level rather than at the macro level. And the way that I thought about doing that, for instance, was to think about, on the question of fonts, was to say, oh, well, I know that I'm going to want to use different fonts. So I can imagine having this is written in C++, because that's the language I happen to know. I can imagine that there's some sort of interface to a font, quite generically. The typesetting engine wants to ask, what are the extents of these glyphs, and what's the glyph to code point mapping, and how do I request extensible fonts? And then under the hood, legacy fonts can do what they need to do. OpenType fonts can be passed through to Harfbuzz to get all this information. The usual kind of stuff. I guess I should demonstrate, since I said that I wanted tagging to be an important part of this. Let's look at the Vera PDF verification for the UA2 format, and you can see that this font is humongous, so it's hard to read, but indeed, the file is compliant with the validation profile, a bunch of past rules, failed rules. I'm actually not completely convinced that Vera PDF is an exhaustive and completely correct checker, but there you go. For the kind of test that I'm able to run, this is I think passing the validation test anyway. Maybe there's one other thing that I wanted to demo, because actually not this. Let's actually go ahead and look very briefly at the file. Knowing in advance that you want to output to DVI and PDF and things like that. I need to be sorry. Hard to talk and type at the same time. One of the things that I thought about doing was building up some kind of internal intermediate representation of a page before it gets shipped to an output driver. So a page is built up of a bunch of, put this glyph here and draw this line there and add this tagging annotation over here, and links and artifacts and stuff like this. And the advantage of that is that then if you have a DVI driver, it can process information in whatever way it needs to. PDFs can do whatever they need to kind of visually represent the same kind of intermediate representation. So one of the things that I was interested in doing, I'm a scientist, so I give a lot of talks at conferences, so I wanted to have some kind of slide-like presentation technology. Beamer is amazing, but maybe we can do something a little bit with some extra benefits, I suppose. So here, let me just compile this slide sample, and let's just say that I want to output to PDF. And it's going to give me an error because it looks like this slide sample sample.tech on line number 143. I was trying to embed an MP4, and for anyone that's kind of played around with, what were they, the multimedia package and Media 9, maybe remembers how much of a headache it is to kind of embed multimedia assets into PDFs. It's kind of a failing of the standard, not of the engine, right? But we can look, what was this thing that just got generated? It said it was a non-fatal error. It was just some collection of things that were like slides, and if I scroll down to, you wanted to embed an MP4? So sorry, that's not quite going to work out for you. But again, if you know in advance that you're going to want to output to different kinds of backends, you could say, well, if I already have a PDF output mechanism, maybe it's not so bad to output directly to HTML instead, right? And so here, let's go ahead and take a look. Firefox, what was this called? Slide sample.html. And there you go. So here, Tech 82, but it's slightly more modern, right? And so, I wrote a bunch of slides just as samples. These are not particularly interesting, I think, to talk through. Indeed, I think it's interesting to have this kind of intermediate representation of a page. It's kind of a similar idea to what LuaTeX has done with all of their kind of callback mechanisms, but here it's, it's at the engine level. And I think that already opens up things to be done in some interesting ways. Transparency of color is one of those examples that PDF and HTML need to handle very differently. Of course, in HTML, it's just RGBA is just built into it, whereas in PDFs you need to manage external graphic states. And actually, maybe I can go ahead and let's close this. Let's actually look at that really quickly. So if I build this for PDF, but I'm going to say don't compress the PDF. So that means that we can just like inspect it in like a human readable format. You can see that so managing colors and opacity, transparency in PDFs require managing in parallel these external graphic states, whereas in HTML, it's just RGBA, and you just add the opacity as a fourth parameter. So that's kind of nice. Oh, let me go back to the slide sample. Yeah, so color opacity is one of those samples where you have a representation that says I want to have a transparent color, and then the back end does whatever it has to do, right? I built some very silly slide scaling thing. I guess I'm supposed to show that indeed, in HTML you can just say I have some visible region and let me kind of scale the whole thing to match whatever the screen is. That's something that I think I needed to actually connect to projectors and have it work correctly. It's easy to inject JavaScript or CSS using some of the new primitives that I've built into the engine. One advantage of doing math and having this all be at the engine level is that you can actually just say I'm writing the glyphs and the SVG paths directly into the HTML, right? And that means that you don't have to do any dancing about converting TeX to a PNG and embedding that. You can just you have whatever copy pastable math, which is kind of cool. And I don't know if you can see this. There's a 1 pixel bug where the vinculum connects to the SERD, and I just have not been able to track down that bug. But it's one of the many things on the to-do list. I don't know why. I guess I'm just demonstrating that this is all here. Let me inspect the page. Instead of having slides copied over and over again to kind of do the progressive appearance, which is, the Beamer way, you can just say, oh, what I want to have are, classes that are fragments that maybe start at specific, click patterns. And where's the scroll bar? And then you can just build the JavaScript and the CSS that says, oh, fragments are these things that, go from opacity 0 to opacity 1 or something like that. Okay, and of course, the way that I motivated this in the first place, I suppose, was that at the HTML level, embedding an MP4 is trivial. You just say, just do it and autoplay and mute it, or don't autoplay or whatever, and you just generically get the HTML5 controls, which I think is like really useful for presentations. And so this is something that I've had a lot of fun working on. It's got, I think, some advantages. It passes the trip test. Maybe I'll show that really quickly in a second. It's got tagging and accessibility, not at the macro level, but at the engine level. Native support for modern fonts, native support for generic output formats. It's built with concurrency in mind, somewhat more modern coding instead of using web and Pascal. On the other hand, there's just like a ton that's left to be done. I haven't finished doing the eTeX extensions yet, so you can't use LaTeX, just plain TeX, the original engine, and stuff like that. There's a lot of things that are still not quite working right, a lot of work still to be done. That's okay. There's no real documentation yet. The TeX documentation, I think, is legendary and amazing. Maybe most importantly, it was written by an amateur and not by a genius, and so there's a lot about this that I think would benefit from a lot of additional work, let's say. Let me just go ahead and kind of show that I've kind of built the trip test into the testing framework of the project in the first place, and so it sets up and it runs the original trip test comparing the original screen output and the log files and the DVI files and stuff like that. And you can see that I am still not passing the eTeX version of the trip test because those things aren't done yet. And actually, I'm not sure what I've changed to corrupt the original. This is which one is this? This is the terminal output of the trip test, so I'm going to have to go back and fix that. Like I said, lots to be done. And I think this is really not yet ready to be released in any meaningful way. It's at the point where I can start to use it myself, which is amazing for internal projects. But I thought it was finally in a good spot to kind of demo some of the things that it can do, get some feedback from the community. If you thought this was interesting, or if you have questions, or if you want to learn more, maybe leave some messages below, and I'll be happy to kind of maybe start writing a little bit more, recording a few more videos, walking through how all of this engine actually works. All right.